makes with a tangent. Let's say this is a tangent. The angle which a chord makes with a tangent is equal to the angle in the alternate segment. So let's say this angle, if this angle is A, this is a chord because a line that is drawn from one part of the circumference and passes without passes and touches the other side of the circumference without passing through the center is a chord. So this is a chord now. The angle which a chord makes with the tangent is equal to the what? Angle in the alternate segment. That means this one will definitely be what? A. Take note of that. And also, if you have this angle which is tangent, which is perpendicular to this tangent, this line perpendicular to this tangent, this place is 90. There's another theorem that is saying this. So I'm trying to agitate your mind and to refresh your memory on we have so many theorems which we always employ when we are faced with questions. So the question determines the theorem we have to apply. There's another one where you have a scenario like this. So you have a scenario like this. Then you have something like this. So this angle, if this whole place is 60 degrees, you have two tangents. If this whole place is 60, this one will definitely be 30, 30. This angle is equal to this angle. Then we can also use, because this is 90, so we can use this side is equal to this side. So we can use parallel, so and so on and so forth. We have so many theorems that back this cycle geometry. That means before you can survive the cycle geometry, you must be able to recall all the theorems in total. So on that note, we are going to appreciate all these theorems that are applied when we are faced with questions. Then the last one is special angles, construction involving special angles. We should know, we should have known how to construct the special angle, these basic angles in our previous lessons. Like your 30 degrees, 45 degrees. In this situation, I just want to have a rough sketch. So in this, if you are to construct 90 is usually the basics. So it's just like picking your compass, mark a point along this region. Then you mark a point somewhere here. So you can put that on this and mark a point here. Put it on this and mark a point here. And you trace this one down. You call this what? You call this 90. You call this 90. So if you want to talk about 45, all you just need to do, 45 is 90 divided by 2. So you can come here and mark a point here. You come here and mark a point here. Then you trace it to the origin here. Then you say you have 45 degrees. Then if it is 30, or let's say 60, if it is 60, you can just make an arc on this line. When you make an arc on this line, you make an arc on this line of equal radius, then you make an arc here. Then you can now come here and mark a point here. The point you have marked here is 60. You mark a point here, that's another 60. And this one is what? Another 60. So you can call this point 120 degrees. Why you call this 60 degrees? So depending on what we are doing, and mostly this of 75, it is more or less like saying 60 plus what? 15 degrees. I'm only trying to refresh your memory because I know it is what you ought to have done in your previous lessons. So, and as we see questions, we'll be able to use all these special angle application to fashion out our answers. are 20 UTME questions designed for this topic, geometry, as shown in figure 1.5b. But before that question, we'd like to take one of the UTME question as an example so that we can really see the picture of what we are dealing with. So let's consider this example. In a regular polygon, each interior angle doubles its corresponding exterior angle. Find the number of sides of the polygon. This is a typical UTME question for a particular year. So I want to use this as an example. But the first thing we need to know here, it is mentioned interior angles. Interior angles. And we know that the sum of all the interior angles of an n-sided polygon is n minus 2 into 180 degrees, or 2n minus 4 into 90 degrees. So I use this or use this. Then we also know that exterior angle is 360 degrees. Now in this question, the question gives us the information that each interior angle doubles its corresponding exterior angle. So what it simply means is that, what is the formula for interior angle? That means interior angle is 2 times exterior angle. So in this situation, what's our interior angle? It is n minus 2 into 180 degrees, and that is 2 times exterior angle. Exterior angle here is 360 degrees. So what we need to do here is, let's open this, n times 180, because this one can be written as n times 180, 180 n, minus 2 times 180, that is minus 360 degrees, equals to this times this, that will definitely give us 720 degrees. Then we'll have 180n equals to, collect like terms, 720 degrees plus 360 degrees. Then we have 180n equals to this plus this, that will definitely give us 360. That will be 1080. So we have 1080. We have 1080 degrees. So we are looking for our n, which is the number of sides as the question has stated. In this situation, how do we get our n? We divide both sides by the coefficient of our n, which is 180 in this regard. So we have 180n divided by 180. 1080 divided by 180. So this 180 can cancel this, and we have our n to be equals to 0 cancel 0. 9 in 18, 2. 9 in 10, 1, remainder 1. 9 in this, 12. 2 here 1, 2 here 6. So definitely it will now be 6. So the number of sides will now be what? 6 sides. So that is how to approach this kind of question. We know our interior angle, we also know our exterior angle. And you can see the way our answer comes out naturally. So let's see some other example, because as far as this topic is concerned, we are going to be talking about those topics, those subtopics that have been itemized previously. We have lines and angles, we have polygons, which I just solved, we have cycle theorem, then identify construction procedures. So in this situation, we have to use this example, which is a typical example of questions in UTME. So let's see some other example. Look at what we have here. The first 4 questions under this figure 1.5b that contains 20 questions. Out of the 20 questions, we have the first 4 here. The first 4, the number 1 says that we are given a cycle. This is an example of a cycle geometry. Question that is tested on cycle geometry. In the cycling quadrilateral above, find PRO. In this situation, the first thing we need to ask ourselves, because I have stated all the theorem guiding cycle geometry earlier in our previous class. So if you look at this particular cycle geometry very well, you discover that this there is this particular quadrilateral, the edges are touching the circles. How many of the edges are touching the circle? 1, 2, 3, 4. Take note of that. Each time you have 4 edges touching the circle, they call it cyclic quadrilateral. You can see the way it has been stated. And by virtue of cyclic quadrilaterals, take note, we know that this is our diagram. This is our diagram. By virtue of the first thing you need to note as far as cycle geometry is concerned is that when you are dealing with a cyclic quadrilateral such that the 4 edges are touching the circle, the opposite angles of a cyclic quadrilaterals are supplementary. So what it simply means is that this angle plus this angle must be added up to 180 degrees. This angle plus this angle must be added up to 180 degrees. But here the question asks us to look for what? PRO, angle PRO, that's Y. The question asks us to look for Y in this respect. If you look at this question very well, you discover that it is a cyclic quadrilateral. So automatically, and apart from the fact that we are going to be looking at 2 theorems combining here. The first one is cyclic quadrilateral, which I have stated that the opposite angles are supplementary. This angle plus this angle must be 180. This angle plus this angle must be 180. Another thing I can see here is what is known as what? Angle in the same segment. Look at this place. This place is 50 degrees. Automatically, this place too will be 50 degrees. Simply because angle in the same, that means if you have a circle and you have a scenario like this. This is the center, this line passes through the center to this edge, and this one too passes through the center to this edge. If this place is A, this place will also be A. That is angle in the same segment. This is in